All right, hello everybody. Before we begin, I just wanted to introduce myself. My name is Chris Radcliffe. I'm one of the lecturers for 1181, 1182, and I'm recording this on the 31st of March, so I think by the time a lot of you will have seen this, probably things will be different yet again in the world, and so I just wanted to take a second to say that I hope you're all coping well, you and your families are well, but now I'm going to switch over the slides and take us through this Project 23 lecture. Okay, so switching over to the slides here. In our value creation process, here we are over here communicating societal benefits. You know, the reason that we've followed this whole process is that so that we get to a point where we know that what we've designed, what we've prototyped is useful to users, right? We started with the defining the problem and understanding user needs so that when we got to this point, we wouldn't be surprised to find, oh, this actually isn't useful to anybody. But now is the time where we have to really think in a more detailed way of what these benefits are and what the implications and impacts might be. And so as per usual, you know, our learning objectives here are to communicate effectively with a range of audiences as always, but also number 10 down here, to continue to understand and be able to create connections between a project and implications and user needs and values and things like that. And so for this assignment, what we're going to ask you to do is to determine the value and viability of your system. And so we'll ask you to create a table and write some language about how your system, your project addresses both social and economic impact. For economic costs, we're going to ask you to provide basically a table of system elements defined as startup costs. So what items will contribute to startup costs, to operating costs, to maintenance costs, and I'll show you an example of that here in a second, but also describing forms of potential revenue, including fees, subsidies, grant funding, and these sorts of things. The goal here is just to think through what the economics of the system could look like. Obviously, this is a really important part of any project management, and it's interesting to do these kinds of thoughts experiments now that you've put so much work into defining a project. And the second part of this is we'll ask you to provide a list of potential social impacts, and then again, you know, write a little bit of language, a narrative about what those are and how those will be realized in society. And so again, here we are towards the bottom, right? The social and economic value, while this is something that we have had embedded in this whole process from the beginning, here's where we really want to draw it out, describe it, and write about it in detail. And so this is an example of the table that we'll ask you to create. So here you have costs, and you can organize this in different ways depending on the work that you've done. This is an example for that time management app that we've seen previously. And so some of the cost areas in this case would be research, analytics, and wireframing, which is the same as prototyping for an app. And you can see that what we're doing here is we're listing these in terms of dollar signs. So $1 being less cost, less money, and two, $3 signs being more. And this is, you know, we're not asking you to come up with numbers that wouldn't really be feasible for us at this moment, but just kind of general ideas of where you see the largest costs being for the work, for the project that you've developed. Design, style, branding, quality assurance, and you can think of different areas here depending on what you've done. Value can come from sales, advertising. Again, this is a place to put subsidies, government funding, grant funding, and those sorts of things. And then at the bottom here, you see the social value part. And instead of dollar signs here, you can use stars to kind of indicate different weights of social value. And so for each project, for each group, this table might look different. This is just an example for you to work off of. And so in the assignment, you'll create one of these, and then below you'll kind of describe each of these elements in written language to kind of, you know, share your thoughts with us in a better or more detailed way. And so the concept of social impact, right? I think this is kind of an opportune moment to talk about it when we are living in a situation where the health of everybody, you know, impacts the health of all. And so with the coronavirus and things like it, anywhere you have societies, systems that aren't able to deal with it or react in a you know, comprehensive and healthy way, that actually increases the risk for everybody. And so when we think about this in the context of engineering work, you know, our goal as engineers is to create a more efficient society, and one where our work is contributing to the needs of communities and societies around the world. And one of the frameworks that have kind of been developed to think about this is this idea called shared value. And this is something you can look up online, and there's a lot of articles and published work about it. But the idea here is that if you can find, the nexus where society's needs overlap with, expertise and assets of, in our case, engineers, but also an opportunity for business, you kind of hit the sweet spot, right? Where you're kind of checking all of these different boxes in a way that's synergistic, in a way that's going to be a sustainable solution. And so basically, to think about this in other ways, shared value is a policy or practice that enhances competitiveness of a company while simultaneously advancing social conditions, economic conditions in the communities in which it operates. What it's not, and what you kind of have to be careful about, is that it's different from philanthropy. You could have an organization, a company, a project that is actually really damaging to society, to communities, to the environment. And you can be philanthropic in that you can still be donating money. If you have a company that is destroying the environment and then you turn around and donate $1 million to Greenpeace, the overall impact might not be positive. So that's not an example of shared value. It's also not, related to personal values, because we can't just have something that is pushing our own personal beliefs, our own political views, philosophical views. You kind of have to have a way to understand objectively that the impact you're having is positive. And it's also different from regulatory compliance, right? So an example of this is car emissions. If you are following the regulations on what is allowed for car emissions, you might be legally in compliance, but that might not be the best thing for communities, for the environment. Same with, fracking is a good example, where fracking liquids, fracking chemicals are proprietary, and so companies that use them don't need to share what's in those mixes. And while that's regulatorily, while it's legally compliant, it might be really difficult for communities, for governments, for states to understand how to clean those things up if there's a spill, since they don't know and they're not allowed to know what's in it. So an example of something that in my mind fits the bill is something like phone banking. So if you have heard of this before, you'll know that phone banking has really swept the world. Anywhere in the world you're going to find cell phones, smartphones, or normal phones like in this picture. And in a lot of the places around the world, like in rural areas, especially in developing countries, what you find is that ATMs, banks are really hard to access. They can be miles and miles away. It can take you all day just to get to an ATM, and when you get there, you might find the ATM's out of money anyway. And so what banks have done are created these little really simple apps that connect to bank accounts and allow people to transfer money with a phone, even just with a text-based phone, which is, allowed a social benefit in that people who struggled to get access to cash previously now don't need to do that, saving them time, saving them effort. Meanwhile, the banks are able to increase membership and use their own expertise and their own assets to make this difference. And so it's a win-win situation. Another example of this, where engineering and coding and tech kind of comes in, is there's an organization called WOTC that tries to connect people around the world who need surgeries but can't afford them with donors. So you would donate money to this organization. They would help fund, for example, LASIK surgery for a child who might not have access to optometrists or eyeglasses. And so what a friend of mine actually does is he lived in Burundi for a year with his wife who's from there. He lived in Kenya, but his wife is from Burundi. And he is a coder, he's an app guy, and he was developing an app to help the hospital record and save and make available records of patients, which is something that they were kind of understaffed and didn't have the expertise or the time to really do. And so his work is involved in creating the records and making them accessible so that WOTC and organizations like this can identify and find and connect donors with people who need support. And so that's an example where you've kind of really hit, this middle part that we've been talking about, where it's useful, extremely useful to somebody, it's desirable, and if you can create an app or you can create the tech or the mobile phone banking correctly, it can be usable too, and you've created something with a lot of value. Another example of this, is in the current situation is Battelle, who have transitioned a disinfectant process that they developed for the Ebola outbreak into disinfecting N95 masks for coronavirus. And so, this is an engineering process that they developed that they can get government funding to run and to process. And meanwhile, the impact of what they're doing is saving lives of healthcare workers and first responders who need access to these things right now. And so when it comes to value creation, as you're thinking about this assignment, as you're thinking about how to frame this in your own projects, there's a few ways to think about value creation, right? You can think about the paycheck, the dividends, selling out the company for investors, because you're always going to need people to help you out to get your project off the ground. You can think about dividends as well, buyout of ownership, sale of the company as well. When it comes to social value, providing services, solutions for underserved, creating jobs, stimulating the economy, those are all pieces of social value, and you can think of more too depending on what you're working on. As a quick example, for a transportation system, the example of CODA, this data was from the 2016 CODA bus system, where total revenues from operations from riders were about 20 million, total operating expenses were 150, and then revenue from assistance being government funding and taxpayer money, 135. And so the value of CODA isn't coming from a profit margin, it's coming from the social value that it creates. And so within this example, we have cost buckets, right? We have the startup costs that would be, in this case, buying the vehicles, buying the structures for bus stops, things like that. You'd have ongoing operating costs, labor and energy to operate, overhead, maintenance, those sorts of things. And then taxes, interest payments, licenses, fees. These are all potential cost buckets for your project at large, whatever that might be. And then revenue buckets can be things like user fees, taxpayer subsidies, institutional subsidies, etc. And then, for CODA, thinking about social value, you can help people with limited access to transportation, access health services, help the elderly, the disabled, increase socioeconomic mobility and opportunities, just simply help people get to work, decrease traffic, things like that, right? And you can do some simple calculations to see, for example, if you are having more people ride the bus than their own vehicles, how much money you can save in gas mileage, things like that. If you were to upgrade the vehicle and make it more fuel efficient, how much money would you save? And so these are good ways to kind of try to interpret social value into an economic and dollars kind of a value. And so even for CODA or nonprofit organizations, this profit equals revenue minus costs is still a really important thing that has to be considered. Profits, of course, can be used in a number of ways. They can pay back startup costs, they can supply returns to investors, they can expand the business, you can pay your people better, all these sorts of things. For not-for-profit companies, this still needs to be balanced, but in this case, revenue can take on the form of grant funding, can take on the form of subsidies or social value created in other ways. And so this equation you should try to balance it. In some ways, you're kind of creating this table. That doesn't mean that these dollar signs have to match up exactly, but it's something that you can talk about in the written part of the assignment. And so, looking back on those last few slides, hopefully that'll give you enough to kind of create, these rows and what they will look like. And also the social value part, as well as the income that you might receive from this project being implemented. And so these are some of the questions you can ask yourself about, to complete this assignment. These are all basically covering the things that I just spoke about, but can be helpful to guide you. You can also think about scalability in terms of future potential value as you were considering this table and this assignment. So are there follow-on products that use the same tooling, same processes that you could imagine? Can your product spread to additional markets? The same thing with new applications, or the same thing with secondary markets. These are also potential ways to discuss and think about and conceptualize the value of your project. So again, the deliverables here, create that table, write some language for us so we understand your thought process about these, and include the economic costs, operating costs, startup costs, as well as revenue, and the social impact value as well. And so, I think just to kind of continue on a little bit with the social impact side of this, everything that I spoke about before, that's all you need with regard to the assignment, with regard to this lecture. But I think it's a good time to just kind of have some provocative, thinking and questions raised about the impact of engineers. We have a lot of impact in, say, in the way that technology is used in society, in the way that technology is developed, about who it's developed for, and the problems that it is meant to and targeted to answer. And I think that it's really important for young engineers now to consider and to work towards developing a broad skill set, a broad level of understanding of not only the problems that you'll be given, that you'll be asked to solve, but the context of those problems. So where does that problem come from? Is it really a problem? Who is it a problem for? And then the implications of the solutions in the work, right? So who is impacted by this work? In what ways are they impacted? What are some of the unexpected consequences? You can look through plenty of examples in the history of engineering where the solution has raised more issues than it solved. And so a question arises of, if I'm an engineer working in this business or that business, how do I think about this? What questions can I ask myself, to kind of get to the bottom of the true impact of what I'm doing? And so some of these questions are, does your work support systems that are performing poorly and should be replaced? That's actually a really provocative question, because there's a lot of areas of society that we could point that question to, and we would say, this probably isn't working well and should be replaced, but it's so deeply embedded that what are we to do, right? Another question is, does my work create dangerous or uncontrolled side effects? It's an obvious one, but a really important one. Do I have a role in formulating the why of a technology, right? So why is this being used and who is it being used for? And does my work uphold the dignity of people? This is the reading that this all comes from. If you ever want to read it, it's a nice little chapter about the social function of engineering. And so let's take that first question and turn it towards something that is very everyday and very deeply embedded in our society, which is the automobile. And just to preface this a little bit, my goal here isn't to convince or persuade anybody of anything, but just to ask some questions and provide some sources that can lead you into kind of a deeper understanding of these things. But we know we live in a country where about 30% of our greenhouse gas emissions come from transportation. A large chunk of that is going to come from individually owned automobiles. We also know that air pollution is causing deaths, right? It's actually limiting and shortening people's lifespans due to issues with respiratory illness. And we know that it's costing economies a huge amount of money. We also know scientists are telling us, are indicating and reporting that the effects of climate change are coming in greater ways. It's already impacting a lot of people in the world. And it's something that, the window of opportunity to change it, according to, some of these reports, is closing rapidly. And so we have to ask ourselves, especially as the engineers and the people who are developing this technology, what is the purpose of this and what is the course of action we should take? What's really interesting now is we kind of have this case study due to the coronavirus of what the impacts of cutting down on some of these things are. And so I'll play this video real quick, but it basically shows,
based on data from the Copernicus Sentinel-5P satellite, this animation shows the variation of nitrogen dioxide emissions from the 20th of December 2019 to the 16th of March 2020.
And so you can see there just how big of an impact it has. And obviously this was a very radical and extreme change, right? Everybody basically stopped going anywhere. Factories shut down, the economy shut down. That's not a sustainable change, but it's interesting to see how quickly things can shift if we take certain actions. And so with respect to vehicles, why is it that we are consistently building highways instead of public transportation? What is it about our policy? What is it about our society that we haven't, instituted really, really, really strict emission standards for vehicles and cars? These are all questions that I think engineers should be knowledgeable about. You might not be in a situation where you can make these changes. None of us can flip a switch and tell our society or the world to stop using cars. But what it takes is, everybody working on a problem, working on something like this to understand all these contexts so that collectively, things can be steered in directions that are good, that provide the most good for everybody. Thinking through these questions a little bit more, you might ask yourself, or you might say, okay, well, electric vehicles is the way forward. We've got this technology now. We expand, the electric vehicle fleet, and we can replace all cars by a certain date with non-emission, polluting vehicles. And so there's some issues there, though, right? So any solution is going to have questions related to it. So, for example, in this case, if I have an electric vehicle in Ohio, what good is that really doing when that electricity is coming from coal and natural gas? We can think about the sources of these fuels is another question of, something that might need to be replaced. For fracking, for coal mining, in the fracking industry specifically, a lot of these companies are going bankrupt. There's, billions and billions of dollars of debt amassing, and meanwhile they're environmentally challenging, right? We know that there are spills. We know that there are issues related to this. And so what are the ways that we get our energy, and how can we think about doing this in a way that doesn't create debt and doesn't degrade the environment? Are there ways that we can shift and do that? The other things to think about with regard to electric vehicles is where the materials come from. I was a solar engineer in grad school, and this was something that never really came up, and I don't really understand why. We would do research on solar panels that used certain rare elements, and the question was never really raised, where are these elements coming from? If our work does get to large scale and mass production, where will those elements come from then, and who will be impacted by that supply chain, right? The supply chain of these things is extremely important. Some of the materials and minerals who make the batteries and the electronics in everything we use, right? That's the cell phones that you probably have at your hand, your iPad, your laptop, right? These things contain minerals that are mined in places where you have 7-year-olds mining for $1 a day, which is crazy, right? And it should not be that way. And so this is another thing that as a company is something that you're designing, something you're working for, to look into the supply chain and understand carefully where things are coming from. Here's a link that gives more information about what are called conflict minerals. Not only are there really, really harsh and unfair working conditions, but also the revenue and the profit that comes from these mines often goes to fuel and sustained armed violence in different places around the world. And so, you can go down a rabbit hole reading about that, but it's something to really consider and to think about, because a lot of what we do as engineers utilizes materials that have to come from somewhere, and they're extracted from somewhere. And so the impact on those people is a big part of the social impact of what you do as an engineer. You might say that, okay, we have electric vehicles, we have solar power, there's the solution, right? And yet again, we need to be thoughtful and ask important questions about things like solar. I personally am an advocate of solar, but I think there's a lot of issues with it. There's environmental justice questions related to solar power. For example, if you build like an 8 square mile solar park in the desert, or even in anywhere for that matter, what they're finding is that you're actually not offsetting the carbon, because the ecosystems that you replaced were actually doing a better job of capturing carbon than the solar is offsetting from a fossil fuel. And so that's something that I think most people would never have really thought about. There is a huge amount of power in natural ecosystems to sequester carbon, and that's something that really should be understood by people who are pursuing and advocating for solar. Additionally, what happens to these panels? What happens to the inverters and charge controllers and batteries when they're old? There is an electronic waste crisis in the world, and there's all kinds of waste crises in the world with plastic and all the other stuff. But what's especially important about e-waste, electronic waste, is that a lot of the stuff in there are toxic chemicals. And so I think one area that engineers could really play an extremely positive role is in creating and designing things that don't get thrown away, right? So let's say that you design something that it's end of life, it just transforms into another use, right? Like think about an escalator. When an escalator breaks, it's just a staircase. It's still usable, right? So things like that, I think, is a really interesting avenue for engineers to explore, to think of end-of-life uses for things when they break or when they're not useful anymore. And so getting back to this, right, like uncontrolled side effects such as e-waste, do I have a role in formulating the why of a technology? Does my work uphold the dignity of people? One more example I'll throw out there before I finish is artificial intelligence. So it's something that I find students are really, really interested in, really excited to work on, especially with the 1181 SDP project. But we have to think about, for one, who is AI for? Is it, meant to be a stock market trading mechanism that helps enrich people? Or is it meant to be something that helps us, hand out and create healthcare solutions for people who need them, right? There's a lot of ways that AI can be deployed, and it can be really problematic, and it can be really beneficial. And so once again, the engineer and everybody who works in these sorts of organizations needs to be really well informed about the risks and the potential benefits. One thing that people are finding is that within AI, racism is coming out of these programs, these algorithms, and these chatbots or whatever. If you've heard of the, I forgot the name of the Microsoft chatbot. I think it was Tay maybe or something like that. But really, really crazy. They released it, and it was going to be a Twitter bot just to chat with people and learn how to be social from other Twitter users. And I think within just a few days, it had to be taken down because I don't know if people were messing with it or if it was just seeing what's naturally out there. But it started spitting out some really racist and troubling messages, and so they had to take it down really quickly. But more damaging, they've found racial bias in major healthcare algorithms that have affected millions of people. And so for artificial intelligence and things like that, what is the AI learning from, right? If it's learning from us, we have a lot of issues with bias, and we have a society that has been deeply racist and misogynistic in the United States at least, but the world over, there's issues with how things are distributed and shared and what people get access to resources and which people don't. And so if we're creating AI based on us or learning from us, we have to be really, really, really careful that, we're analyzing our own biases, we're analyzing our own societies and historical context so that we're not creating something that is just going to exacerbate the problems that we see and have seen in history. And so, again, I throw all this out there just as things to think about, provocative questions to be asking yourself. As you kind of move through not only this project, but also, into your careers and into your work. And it's important to say that in none of these cases am I saying, oh, you shouldn't take a job or an internship at Honda or anything like that. But just to be thoughtful, and raise these conversations with coworkers and get different perspectives and come to your own conclusions. Because, there's a lot of information out there, and there's a lot of different ways to approach these things and think about these things, and a lot of different strategies for maximizing and enhancing the impact of the work you do. But I'll leave it at there. So again, hope you all are doing well. I hope that the impact that you are feeling from this crisis is minimal, and that whatever impact you are feeling, that you are able to get through it, and hopefully, this will pass and that there will be light at the end of the tunnel. But stay well, everybody. I'll talk to you later.